Hello! Yes, and welcome to our Objective 5.6 sample problems, where we're going to practice solving polynomial equations. So let's dive right in. This first problem that they have us is a polynomial equation, and they actually give us a 0. So let's start by graphing this, kind of look at what we got here. We have 6x to the 5th plus 5x to the 4th minus 28x to the 3rd minus 20x squared plus 16x. So they tell us x equals 1/2. Let's see if there's some other zeros we can see here. Let's see if this will graph. There we go. X equals 1/2. Whoa, look at all that. Okay, we got a lot here, don't we? So the first thing I notice is we don't have a constant here. So that means x is a factor for all of these terms. So in addition to x equals 1/2, I also know that x equals 0. All right, because I don't have a plus c here, right? X is a common factor for all of these terms. So if x equals 1/2, let's build off that factor. That would be the factor 2x minus 1, right? So what I want to do is I want to do some long division, and I want to divide out 2x minus 1 from this polynomial. So 6x to the 5th plus 5x to the 4th minus 28x to the 3rd minus 20x squared plus 16x. And you know what I just noticed? I'm going to change all this. I know x equals 0. I'm going to get rid of these. I'm going to change all of these degrees by 1. All right, I'm going to factor out x. So this will be 4, 3, 2, 1. I really don't need to write the 1, but I did that for you. All right, so let's do this here. 2x times what gives me 6x to the 4th? Well, that would be 3x to the 3rd. So that would give me 6x to the 4th minus 3x to the 3rd. When I do my multiplication here, subtract, I'd get 8x to the 3rd minus 28x squared. 2x times what gives me 8x to the 3rd? That would be 4x squared. Do my multiplying, 8x to the 3rd minus 4x squared. Do my subtraction. So subtracting a negative would give me a positive. So this would become negative 24x squared. Drop my negative 20x. 2x times what gives me negative 24x squared? Negative 12x. So that would be negative 24x squared. Negative 12x times negative 1 would become positive 12x, which I would need to subtract. And that would give me negative 32x, bring down my negative 16. 2x times what gives me negative 32x? Well, that would be negative 16, right? And then when I do my multiplying, hey, what do you know? I'm going to end up with a remainder of 0. That tells me we did something right. So that gives me the polynomial 3x to the 3rd plus 4x squared minus 12x minus 16. And I think this one's factorable by grouping 4 terms. I see my pattern here, 3, 4, 12, 16. So let's give this a shot. Let's see if we can't factor this by grouping. I could take out x squared from my first term, and I'd be left with 3x plus 4. I can take out negative 4 from my second and be left with 3x plus 4. So that means my factors here would be x squared minus 4 and 3x plus 4. Wow. All right. Now, to solve, set each factor equal to 0. X squared minus 4 equals 0. 3x plus 4 equals 0. So that means x squared would equal 4, which means take the square root. X would equal plus or minus 2. If I look at my graph, I can see a negative 2 and a positive 2 as x-intercept, so that's good. And then 3x would equal negative 4, which means x would equal negative 4/3, which I can kind of see in my graph as well right about there. All right, so with that being said, let's count our zeros. We have 1/2. That was our first 0. X equals 0. We saw that because there was an x in common everywhere. And then plus or minus 2. and then negative 4/3. That gives me the 5 zeros I need for this 5th degree polynomial. So let's go ahead and write this out in factored form. So we'd say f of x equals, let's see, we'd say x times 2x minus 1 times x plus 2 times x minus 2 times 3x plus 4. And there we have our polynomial in factored form. So cool. All right, let's look at letter B here. 5x to the fourth plus 41x to the third plus 89. They tell me x equals negative 2 plus I. All right, well, if x equals negative 2 plus I, we know x must also equal negative 2 minus I. So let's do some multiplication with these factors. All right, so I'm going to create the factors here. So this, my negative 2 plus I would come from the factor of x plus 2 minus I. Negative x equals negative 2 minus I would be x plus 2 plus I. And we're going to multiply these out. Now remember, if we do this right, anything with an I in it should cancel. So x times x is x squared. X times 2 is positive 2x. X times I is xi. 2 times x is 2x. 2 times 2 is 4. 2 times I is 2i. Negative I times x would be negative xi. Negative I times 2 would be negative 2i, and negative I times I would be negative I squared. So we have a positive xi, we have a negative xi. We have positive 2i, we have negative 2i. What does I squared become? Negative 1. So this would become plus 1, right? Subtracting negative 1. Combine my like terms, I get x squared plus 4x plus 5. And that's going to be what I do some long division with. So let's check this out over here, get this all set up. X squared plus 4x plus 5 would be my divisor. My dividend would be this polynomial. 5x to the fourth plus 41x to the third plus 89x squared plus 25x minus 100. All right, x squared times what gives me 5x to the fourth? Well, that would be 5x squared. That would give me 5x to the fourth plus 20x to the third plus 25x squared. And I'm going to subtract that entire value. And that'll give me 21x to the third. 89 minus 25 would be what? 64 squared, and bring down the positive 25x. X squared times what gives me 21x to the third? 21x. So 21x times x squared would be 21x to the third. 21 times 4 would be plus, wouldn't that be 84? And then 21 times 5 would be what, 105? Wow. So let's subtract this, see what we're left with. We'd get negative 20 x squared minus 80x, and then bring down my negative 100. So x squared times what gives me negative 20x? That'd be negative 20. All right, and sure enough, when I multiply this out, this is going to work out nicely, right? I get my remainder of 0, which tells me I'm on the right path. Everything is a factor here. So that leaves me with the polynomial, the quadratic in this case, 5x squared plus 21x minus 20. So that's the new thing I need to solve here. Now, is that factorable? 5 times negative 20 would be negative 100. Factors of negative 100 that add up to 21. I think that is, right? Because negative 100, I could do positive 25 and negative 4. So yeah, this is factorable. Awesome. So I'm going to rewrite this as 5x squared plus 25x minus 4x minus 20, and then do some factoring by grouping. I can take out a 5x to leave me with x plus 5. I can take out a negative 4 to leave me with x plus 5. And that tells me my factors are 5x minus 4 times x plus 5. Now set each of those equal to 0, and we would find that x equals 4/5 and x equals negative 5. So that is 2 of my zeros. I have my 2 from negative 2 plus I, negative 2 minus I, and that's the total I need, right? Because this is a 4th degree polynomial. So let's write these in factored form. Let's see how we do here. So we'll say f of x equals, let me zoom out a bit so we can still see all the zeros here. So we'll say f of x equals 5x minus 4 times x plus 5. Now our imaginary factors, x plus 2 minus I and x plus 2 plus I. There we go. Awesome. So now let's check in if they don't give us any zeros, and we have to do this all from scratch, right? So remember, the first step in this process is graphing. Every time we gotta graph. That is always the first step. So we say x to the third minus 6x squared plus 13x and then minus 10. Let's hit graph. And hopefully we can find a zero that we can use. Looks like 2. All right, let's double check that here. Gonna try to calculate. There we go. Go to the left, go to the right. Oh my goodness, we're mobile. Let's try to get this back over here. There we go. There you go. And it is 2, indeed. So we think that x equals 2. Do not know what is happening here. There we go. X equals 2. So let's use synthetic division to divide that out. 1, negative 6, 13, negative 10. And again, we should get a remainder of 0. 2 times 1 is 2. Negative 6 plus 2 is negative 4. 2 times negative 4 is negative 8. 13 minus 8 is positive 5. 2 times 5 is positive 10. Hey, what do you know? We nailed it. And then we get x squared minus 4x plus 5. I do not believe this is factorable, nor do I think this is going to give us rational. I think this is going to give us some imaginary zeros. So let's use our quadratic formula to work through this here. So we'll say x equals the opposite of b, negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 5 all over 2 times 1. So x will equal 4 plus or minus negative 4 squared would be 16. Negative 4 times 5 would be negative 20 over 2. X equals 4 plus or minus square root of negative 4 over 2. Now, what is the square root of negative 4? 2i. So this is 4 plus or minus 2i over 2. We can divide out a 2, we'd get 2 plus or minus I. All right, and that would be my 3 zeros that I need, right? X equals 2, right? This is a third degree polynomial. X equals 2 is my first, and then here's zeros 2 and 3. So in factored form, f of x equals x minus 2, x minus 2 minus I, and x minus 2 plus I. Fantastic. All right, let's try one more. One more, make sure we're feeling confident. X to the 5th. Well, okay. 5th degree polynomial, so I know I'm looking for 5 zeros. I see that x is common for everything, so I know x equals 0 right away. I can do that. So now that's not going to be very helpful in the dividing out process, but let's see if there's another 0 or 2 we can divide out looking at our graph. So we'll say x to the 5th minus 7x to the 4th plus 10x to the 3rd plus 14x squared minus 24x. Graph it. Show me something good. Show me the money. Okay. Okay, so I see this looks to be 3. 1, 2, 3. Let's figure that out and make sure. I definitely see it cross at 0, but again, that's not helpful with my synthetic division 3. All right, so let's use x equals 3. do some synthetic division here. Now I'm going to go ahead and say we divide out this x equals 0. So this would be a fourth degree. 1, negative 7, 10, 14, negative 24, where negative 24 would be our constant. So if I should get a remainder of 0 if I do this right. Negative 7 plus 3 is negative 4, gives me negative 12. 10 minus 12 is 2. 3 times 2 is positive 6. 14 plus 6. Oh, sorry, negative 2. See, and I would have gotten that wrong. 14 minus 6 is 8. 3 times 8, positive 24. There we go. All right. Now it also looks like 4 is a 0. Let's give that a shot while we're at it. 1, negative 4, negative 2, and 8. Drop the 1. That'd be positive 4. 0, 4 times 0 is 0. Negative 2. Just give me negative 8. Aha. So this tells me that x squared minus 2 equals 0. So I have found 3 of my zeros, and my final 2 are right here in this quadratic. So all I need to do is solve that. X squared minus 2 equals 0. So that means x squared equals 2. Take the square root of those. X equals plus or minus the square root of 2. All right, so there would be my 5 zeros. Now let's write this in factored form. We'd say f of x equals x times x minus 3 times x minus 4 times x minus the square root of 2 times x plus the square root of 2. And there we have it. We are solving polynomials, rewriting them with linear factors. This is really tough stuff. I'm really proud of you guys for doing well on this, trying your best. If you have questions, definitely ask. This is complicated stuff. Like I said, this is kind of this is the boss of this unit. All right, making sure everything we've been working on has led to this. All right, so if you have questions, definitely reach out and ask. Otherwise, get started on those practice problems. Let's see how we do. This is Mr. Carter signing off. I'll see you next time.